Hi everyone, in this short video on the subject of continuum mechanics, I will present the fundamental of constitutive law. To illustrate them in a fun way, I will perform a small experiment in the kitchen to demonstrate the visible effects of a constitutive law. In continuum mechanics, a constitutive law is an equation that relates the physical properties of a material to its mechanical behavior. Its law is to predict how the material will react under the influence of different forces or stresses. Example include the deformation of a material under applied load, heat transfer, or the behavior of a fluid during flow. There are different constitutive laws, such as Hooke's law. It states that the deformation of a solid is directly proportional to the applied stress, as long as the stress remains within the material elastic limits. We can observe the deformation of a wooden stick under the force applied by my finger. Now, let's move on to Newtonian fluids. These are fluids with constant viscosity regardless of applied stress. This means that the resistance to flow of the fluid is directly proportional to the shear rate, which is the rate of deformation of the fluid. It is described by the formula where mu represents the dynamic viscosity coefficient equal to the shear rate divided by the velocity gradient perpendicular to the direction of the shear. Note that the dynamic viscosity coefficient mu depends on temperature and pressure. Let's move on to an experiment demonstrating the difference in behavior of fluids based on their viscosity coefficients. For this, I have chosen fluids commonly found in our kitchen, milk and honey at 20 degrees Celsius. Milk has been chosen for its visual effect. Let's consider the Navier-Stokes equation. Honey has a higher viscosity than milk by a factor around 10,000, which means it is thicker and more resistant to flow. The density is different but not significant. Thus, only the parameter of dynamic viscosity mu, specific to the liquid, changed significantly between the samples. The experiment involves feeding fluids into a rotating funnel driven by a drill. The higher the viscosity is, the more difficult it is for the fluid to move quickly and therefore to exit the funnel, as you can see with honey and milk. It should be noted that other factors can come into play, such as surface tension, which can make a liquid more or less wetting depending on its nature. This factor is particularly noticeable when comparing water and milk. As we can see during the liquid's descent, milk flows uniformly without separating, while water flows in droplets. This is due to the water having a higher surface tension than milk on this surface. And that concludes my presentation. I hope it has been informative or at least entertaining for you.